How can it be that a failed star, which itself does not actually produce any light, nevertheless emits light signals? The James Webb Telescope has now uncovered this mystery. The telescope detected infrared light that would hardly be visible in our world without special technology. In another dimension, however, the dark star could be a brightly shining sun. Brown dwarfs are very unusual objects in the cosmos. They are also known as failed stars because they have some of the properties of a star, but do not have the necessary mass to start the nuclear fusion of hydrogen into helium. However, this would be necessary to produce light and heat. Brown dwarfs are formed by the collapse of gas and dust clouds, similar to real or luminous stars, except that they do not begin to glow like conventional suns after the process. Brown dwarfs have many physical properties that they share with other stars. They have a spherical shape and also a hot surface when they form. The mass of a brown dwarf is typically between about 13 and 80 Jupiter masses. This mass is not sufficient to generate the pressure and temperature in the core required to start hydrogen fusion. However, during their early stages of development, brown dwarfs can fuse deuterium. This is a heavy hydrogen isotope that can also fuse at lower temperatures. However, deuterium supplies are sparse, and so this fusion process only lasts a very short time. Stars that can ignite a complete hydrogen fusion enter the so-called main sequence phase, in which they shine stably for billions of years. Brown dwarfs do not reach this phase. Without the continuous energy source of hydrogen fusion, brown dwarfs cool down over time and become dimmer and dimmer. Nevertheless, they produce a mysterious glow, and the James Webb Telescope has now been able to track this down. The Webb Telescope detects light in a completely different bandwidth than the Hubble telescope does, or other comparable observatories. Webb captures infrared signals and analyzes these waves with 4 special spectrometers. Brown dwarfs reveal their mysterious glow in the infrared range. On the trail of the strange glow. Brown dwarfs used to occupy an intermediate position in the universe. Researchers saw them somewhere between the largest gas planets and the smallest stars. Scientists mainly attributed this to their size and gravity. However, brown dwarfs may be a category of celestial object in their own right that we have so far failed to recognize. The James Webb Space Telescope has discovered an aurora around a brown dwarf that is over 40 light-years away from Earth. This discovery, called W1935, is special not only because this brown dwarf is luminous, but also because it is close to other stars. Normally, brown dwarfs appear in isolation. At first, it was thought that W1935 might be reflecting light from the surrounding stars. But then the JWST discovered methane emissions on W1935. The methane could produce the aurora. The emissions would also be characteristic of the heating of the atmosphere by charged particles traveling along magnetic field lines and colliding with atmospheric particles. The energy presumably comes from the interior of the brown dwarf. Another theory is that interstellar plasma collides with W1935 and triggers the aurora. Interstellar plasma contains far fewer particles than the plasma emitted by stars, and yet the particle density could be sufficient to explain the mysterious glow around the brown dwarf W1935. The plasma density in free space is probably not the same everywhere either. It could be higher in the vicinity of many neighboring stars. If the brown dwarf passes through a region of space with a high plasma density, this could lead to a glow in the infrared spectrum. There is also speculation that the brown dwarf may not be alone. It could be receiving particles from a nearby active moon or another celestial body. It's possible that we have not yet discovered this object, but with the JWST, we have a good chance of unraveling the mystery. A small moon would probably be too small to be detected by the fine spectrometers. But if it is another object, about the size of a planet, Webb could theoretically detect it. Brown dwarfs are not uncommon in space. In fact, they are quite common and make up a large proportion of the smaller stellar population. At first glance, they seem pointless to us, which is how researchers came up with the nickname hindered stars. However, we may have overlooked the fact that this type of star shines in a different class of light and may belong to a world of dark objects that we were unable to see and study before the Webb era. Is there a dark universe? While we know the bright, light-filled universe quite well, the dark universe is still a largely unexplored area. Darkness, dark matter, and dark energy as well as interstellar space make up a large part of the entire cosmos. It's precisely here that we could also find answers to all the phenomena and circumstances that we have not yet found in the world of visible phenomena. For example, we don't even know exactly how matter was created, and we don't know the dynamics that contributed to the creation and development of the universe. This is precisely why researchers came up with the existence of dark matter and dark energy. Although we can neither see nor measure them, we can see their effects. Dark matter is a basic building block of the matrix of our universe, and dark energy is a kind of fuel. But in addition to these two, there are other dark objects, such as brown stars and black holes. These phenomena, and the fact that nothing happens by chance in the universe, have led researchers to the idea of a cosmos that exists right before our eyes, parallel to our world, the dark world. We live in it, and it lives with us, or even co-creates our visible structures. With black holes, we only know that they are there because they exert force, and so we can at least explore them a little. We now know that brown dwarfs emit light, but not in the spectrum that is normally visible to us. Our technical capabilities are improving, and we may soon be able to understand this dark universe. Some researchers even say that we need to understand this mysterious dark dimension in order to better explain our own visible world. From the dark universe to the parallel universe? You may be surprised to hear that there is not only a dark world within our own, but very likely one or more other dimensions and worlds hidden in the darkness. In particle physics, this means that there are gigantic empty spaces between the tiny elementary particles. This is also how researchers came up with the idea that matter is not as solid or material as we have long thought. In fact, matter is more nothing than something. In the particle accelerator in Geneva, researchers conducted a series of experiments in the subatomic range and found smaller particles that behave increasingly strangely instead of solid matter components. Just 100 years ago, an atom was tiny. Today, we know that atoms are by no means the smallest particles. They are made up of many other small building blocks: electrons, neutrons, protons, quanta, quarks, and bosons are just some of these particles. To discover the true purpose of our universe and its blueprint, researchers are looking for clues in the subatomic world. A logical way to unravel the mysteries of the material world is to disassemble matter. But that didn't work quite as well as researchers thought. They reached a threshold where particles become so crazy that they defy measurement according to our old physical rules. The German physicist Werner Heisenberg saw this threshold less than 100 years ago, and the threshold was named Heisenberg's uncertainty after him. Quantum physicists now assume that beyond the threshold, in the world of predominant emptiness and darkness, we are far from having reached the primordial ground of the matrix. Rather, it looks as if the magic point of Heisenberg uncertainty is a transition into an infinite number of previous unknown dimensions. Now imagine this. Whether a brown dwarf, a brightly shining sun, a flower, or your bodies, all are made of matter, and within this matter, there is always the Heisenberg threshold, the darkness, and there is the transition into other possible dimensions. This would mean no less than that thresholds to other dimensions exist, even within you. This quickly makes it clear how little we have really understood about our cosmos and matter. We probably also know very little about ourselves, our lives, and our possibilities. When we observe and analyze brown stars with our super telescopes like James Webb, we are still only scratching the surface despite our highly advanced technology. What stars and our universe really are in their multidimensionality and in the overall cosmic spectacle, we will perhaps understand at some point when we have new technologies or our consciousness has expanded significantly. Phenomena such as brown stars shining in the red light spectrum may have even more secrets, and their existence as apparently blocked stars could have a deeper meaning that we have not yet understood. It's quite conceivable that these only faintly reddish glowing dwarfs are real and brightly shining suns in another dimension. Other worlds could need this light just as much as we benefit from the light of the sun and base our entire lives on it. What do the lights of the cold stars have to do with quanta? Let's look at the dark stars at the quantum level. Quanta are particles of light, carriers of information, and they are essential building blocks of reality. All quanta have a form of energy that they generate or emit. Basically, they are also pure light. But this light is so tiny and small that we cannot see it with our human eyes. No one has ever seen a quantum with their own eyes. Even atoms are actually invisible. We only know that these particles exist because we have detected them experimentally and can study their behavior and effects. Nevertheless, this means that all matter is actually made of pale light. Even brown dwarfs and apparently dark stars are therefore light objects. In the other dimensions near or beyond the blur, bright light worlds could exist that are identical to mythical worlds, divine dimensions, or simply other universes. This finding is consistent with string theory, which states that there are at least 8 other dimensions to our 4, and that these dimensions are all around us, only we don't see them. Subscribe to the channel now to see even more exciting videos.